Today we will be talking about trigonometric identities and how to solve and prove them. Let's say we have 1 minus sine x squared over cos x is equal to cos x. The goal is to prove that this equation is true. The way we do that is by showing that left side is equal to right side. When solving trigonometric equations involving identities, think of it as simplifying and canceling variables on one side to simply show that it is equal to the other side. And we do that by identifying identities within the equation and replacing them with their equivalent identities. So in this example, we know that 1 minus sine x squared comes from the trig identity sine x squared plus cos x squared is equal to 1, where we only have to move the sine x squared to the other side, and we see that it is equal to cos x squared. And we can see that if we sub cos x squared, it makes simplifying the equation much easier since it will cancel the cos x at the bottom, and this leaves us with cos x is equal to cos x, meaning left side is equal to right side, and we have successfully proved this identity. In the next example, we have tan x over secant x is equal to sine x. Since sine x on the right side is the simplest it can be, we will leave it as it is and work with the left side. So we have tan x and secant x. Tan x is equal to sine x over cos x, and secant x is equal to 1 over cos x. We sub these back in the equation, and since it's a fraction divided by fraction, we use the keep, change, flip rule, where you keep the first expression, change division to multiplication, and flip the second expression. When we do that, we can see that the cos x cancels, and all we are left with is sine x is equal to sine x. Since left side is equal to right side, we have proved this identity. Let's look at another example. Let's say we have sine x plus sine x times tan x squared over secant x squared is equal to sine x. Now this seems much more complicated than the previous two examples, but it is actually not as bad as you think. Sometimes it's just one step that makes a big difference. A very common first step in proving trig identities is to first see if you can factor out something. Obviously, we will leave the right side as it is since it's already in the simplest form, but we can factor out sine x from the left side, which leaves us with sine x times 1 plus tan x squared over secant x squared. Now this makes it simpler because we know that 1 plus tan x squared comes from the trig identity secant x squared minus tan x squared is equal to 1, where secant x squared is equal to 1 plus tan x squared. We sub secant x squared back in the equation, and since the left side is being divided by secant x squared, then they cancel completely, which leaves us with sine x is equal to sine x, so left side equals right side, meaning we have successfully proved this identity. Now let's say we have 1 plus sine x over cos x plus 1 minus sine x over cos x is equal to 2 secant x. Now right off the bat we can see that on the left side, both fractions have the same denominator, so we can express it as one fraction, and we see that the sine x cancels out, and 1 plus 1 is 2, so we are left with 2 over cos x. 1 over cos x is equal to secant x, but 2 times 1 over cos x is equal to 2 secant x. Since no matter what the identity is being multiplied with, it stays the same and keeps the coefficient it's being multiplied with. This leaves us with 2 times secant x is equal to 2 times secant x, and since left side equals right side, this identity has been proven. Now what if we had 1 minus cos x over sine x is equal to sine x over 1 plus cos x? Since there isn't a side that is in the simplest form, we will work with both sides together. So we will use common equation operations and trig identities. We will start by multiplying both sides by sine x squared. This way it will cancel on the left side, and you will only have sine x squared on the right side. Next, we will multiply both sides by 1 plus cos x. This will cancel it from the right side, and this way there will be no more fractions. We multiply 1 plus cos x times 1 minus cos x, and see that the cos x cancels, so we are left with 1 minus cos x squared is equal to sine x squared. And we know that using the sine x squared plus cos x squared is equal to 1 identity. 1 minus cos x squared is equal to sine x squared. So when we sub that back in the equation, we get sine x squared is equal to sine x squared. So left side is equal to right side. Therefore, this identity has been proven. Let's look at one more example. We have tan x plus cotan x is equal to sine x squared plus cos x squared over sine x times cos x. As we see, both sides can be simplified, so we will work with both sides. Now we know that tan x is equal to sine x over cos x, and cotan x is equal to 1 over tan x, which equals to cos x over sine x. We also know that sine x squared plus cos x squared is equal to 1. Now we sub these identities back in the equation, and we get sine x over cos x plus cos x over sine x is equal to 1 over sine x times cos x. The next step is finding a common denominator for the left side, which is sine x times cos x, and we will leave the right side as it is. To get the common denominator sine x times cos x, we will multiply the first fraction by sine x and the second fraction by cos x, which will leave us with sine x squared plus cos x squared over sine x times cos x. And this is equivalent to the first expression on the right side when we first started proving this identity. So basically we have 1 over sine x times cos x is equal to q over sine x times cos x. And since left side equals right side, this identity has been proven.